Welcome back, Algebra. We are now into our second unit, and the unit is actually called polynomials. I'll write it here just in case you don't write that every day. So polynomials is the unit, and the topic today is exponents. So it's technically, you'll see this word around the room, or around the screen, monomials. And monomials means, so we can probably figure out mono. That's one. And then, well, meals doesn't necessarily mean this, but it means one term. So one term. We've talked about terms before. In an equation, there are many terms. They're separated by equals and pluses and minuses. And we need to know what to do when the monomials get a little more complicated than what we've been dealing with. So some of it's going to seem really familiar, and some of it's going to seem a little bit new. And you can see this little roadmap. You don't necessarily need to write this, the arrows and everything. It's just a table of contents in a way. So we're going to start with adding and subtracting monomials. This is number one. So let's see what we have for this. And it always starts off with rules. So I don't like learning things by just memorizing rules, but it is helpful to have. If you get stuck, you go back and read quickly what needs to happen. So rules for adding and subtracting monomials is that you add the coefficients. So another word that we see a lot in math that sometimes we forget. So coefficients are the numbers in front of the variables. So you add coefficients only if the variable and exponents are the same. So they have to match exactly. Then keep them the same. Alright, so I'm looking at this first example, and you can probably guess what's going to happen here. If you had 4x plus 5x, we know that that's 9x. No different when there's exponents on it. So 4x squared plus 5x squared is 9x squared, and it stays the same just like it did before when you combine like terms. Next one, subtract the same thing. We're just going to, because of the y squareds match, we can do 2 minus 6 is negative 4, and we keep the y squared. The third one is different. They have different variable terms. So there's literally nothing you can do. This is as simple as it gets. So 12a squared minus 10b squared. And then lastly, we have three terms, or three monomials. And if you notice, they all have n's, but only two of them are exactly the same. So we can combine this one here and this one here, but not the middle one. So negative 4 plus 7 is 3n squared, and we just have to say plus 9n to the third. Alright, so that's adding and subtracting. We're going to move on to the second one, which is multiplying monomials, and this is where it gets a little different. There's a new rule that you probably haven't had to do too much with. So the rule is to first multiply the coefficients. No matter what, you multiply the coefficients, and then combine variables. So that means if there's an a and a b, you just stick them together as a, b. And you also add exponents when they match. And you'll see that in the very first one here. So I have 3a squared times 2a squared. So you multiply the coefficients. That's 3 times 2 is 6. And then you combine variables. So there's only a, so we're going to put a there. And then you add up the exponents. So there's 2 a's in the first one, 5 a's in the second one, for a grand total of 7 a's. And the reason that works is I can write this under here. 3a squared is really 3 times a times a. And then another multiplying, that's the multiplying right there. And then 2 times a times a times a times a, one more. So because multiplication is commutative, in other words, I can do it in any order I want. We choose to do the 3 and the 2 first. That's where the 6 comes from. And when I multiply a times a times a times a, there's 7 of them. So when I multiply 7 a's together, I can rewrite that as a to the 7th. And it just makes for a much nicer written, I would much rather write that than whatever I wrote down there. Alright, next one. The coefficients are both negative, and You might ask yourself, what's the coefficient on this part right here? Well, like many times that happens in math, there's an invisible 1. So it's -4 times -1 is +4. And I add up the 6 and the 5 and I get 11. Next one, 12 times -3 is -36. This time there are 4 x's here, and then, now there's no exponent on that x, but there really is. Just like there was a 1 right here, there's a little 1 right there, and there's a little 1 in this y too. So when I'm adding up my x's, I take the 4 from right here, and the 1 that's right here, and I get 5. And then there is only one y, so you just drop that y down. It doesn't combine with anything else. All right, last one. 100 times 4 is 400. There's 4 d's, but that's it. There's no other d, so I just put d4, d to the 4th, excuse me. And then there are no other k's, so it's going to be k to the 9th. So when that happens, you just stick them together. All right, let's move on to dividing. So in dividing, this is actually my favorite one. It's the opposite of multiplying. You divide the coefficients. So in this first example, that would be 50 divided by 10 is 5. And you cancel the variables. In other words, you actually subtract them. And I'll show you why we say canceling too. So in this case, it'd be 5 minus 3, which is 2. So there'd only be 2 x's left. And the reason this works is, I'll do this up here. So if you have 50 times x 5 times, and then underneath you have 10 times 3 x's, so this reduces to 5. That's where our 5 came from. And then every time you have x over x, they cancel each other out or become 1, because x goes into x 1 time. And that happens 3 times until there's none left on the bottom and only 2 left on top. And that's where our x squared comes from, right there. All right, next, 45 divided by 5 is 9. And then 8 minus 7 is 1. Now you can put 9x to the 1 if you wanted to, but we know that that means the same thing as not writing anything, not writing any exponent. 36 divided by 12 is 3. Now here's where this is a little different. We have a squared over a squared. So if you have a squared over a squared, and you subtract, you get a to the 0. And that's something we're going to talk about in just a moment. But also, we know that, let's pretend a was 5. 5 squared is 25, over 5 squared is 25. 25 over 25 is just 1. So 1 doesn't change anything, which is why when you see this a squared over a squared, you can just cross it off and move on. You don't write a. If you really wanted to, you could write a to the 0, but no one ever leaves their answer like that in the math world. So we're just going to, the a's have gone. And then the same x situation, so it's just plain old x again. All right, this one is a little different because we're going to have to just reduce. So if I break this down and write it like the one up here, let me erase that one up there actually. And then I say a, or 8, excuse me, times 2 a's and 4 x's. And then at the bottom, I need 24, 7 a's. Oh, why did I do this? And 1 x. Okay, now I can reduce 8 over 24. So don't write 3. It's not 3. It's 1 over 3. Or you can say there's a 3 still at the bottom. And then the a's, there's only 2 on top, so they can cancel twice. But now I have these 5 a's left. Notice they're on the bottom. So you don't just put them on the top for no reason. They do stay on the bottom. And then 1 pair of x's can cancel, and there's still 3 on top. So that x to the 3rd stays up there. And there you have your answer. So when you break it down, it's not really that crazy at all. You just leave things where they were and don't move them around because you skipped some steps. Now, this work right here is very helpful to show for a while, but eventually you can skip it once you get the idea of what's happening. All right, next, and I think the last new rule is 0 as an exponent. We touched on it really quick, but the rule is, and this goes against everything that most people think. If I ask people what is anything to the 0 power, they will often tell me 0, because it makes sense. When you multiply by 0, everything turns to 0. When you add 0, nothing happens. It just feels right to say 0, but it's actually 1. And it's because of what I said earlier. When you have that's my white marker. When you have a squared over a squared, we know that's 1. That's not a weird thing, because that's the same number divided, or a number divided by itself is always 1. But if we follow the rules and we say 2 minus 2, this is the same as a to the 2 minus 2, which is a to the 0. It's something in math that just has to work. These two things have to be the same, or else math doesn't work. So it doesn't have to make a whole lot of sense when you raise something to the 0 power, because you can't multiply itself 0 times. It's not what that means. It just has to work for the rest of math to work too. So, the first one here, a to 0, we know that's 1. I wrote it up there. And this next one, this is where the parentheses are incredibly important. That 0 is only attached to the a. We know from PEMDAS that we get less and less powerful as we go down the list. Exponents are really powerful. You have to do those before you do multiplying. So technically, we apply this exponent to the a, and it becomes 1 before we ever multiply by 3. That's something that's hard for people to get set in their brain at first when they learn this. So the answer to this is 3, not 1, because that 0 doesn't affect the 3. Now it's different when there's parentheses. So in this 6a, all of that to the 0 power, now that 0 is affecting the whole thing, and it does become just plain old 1. And next one, this one looks complicated, but in the end, it doesn't even matter what's happening in here. I know that the whole thing is raised to the 0 power, and it's 1. And then lastly, all of 6a is to the 0 power, so it's 4 times 1, which is 4. So you got to really be careful with parentheses when you're talking about 0 exponents. That's how we try to trick you. All right, this is going to be the last slide, and there are 10 questions here, and I'm not doing any of them. So this is going to be up to you. This is going to be the main focus when you come into class next time, is seeing if we got all of these correct. So it's not for a grade, but you're going to want to get them all correct, because who knows? I might bring a surprise in. So you might want to do this on a separate piece of paper. It might be a little easier than having it on your notes. And you're going to do your best. Use the rule, use your notes, go back to watch the video if you're stuck on something. And I think you can probably get all this. Number 8, we didn't do one that was a word problem, but you can figure that out. You're pretty smart. And I think the rest you can do. All right, good luck, and we'll see you later.